Hey all, welcome to chapter 8. We're talking all about linear regression and you're going to have a blast this chapter. I promise you. Okay, please watch this video before Tuesday's class. So important dates. I have no idea, class. Honestly, yeah, I have no idea. Do you have an idea? Because I don't. But you know what I do have for all of you is I have a joke. Why didn't the teddy bear want dessert? Does anyone know? Does anyone know? You'll have to wait till the end of the video to find out. Okay, class. So we're gonna go to Burger King. Do you guys know Burger King? I think, who is it? Someone in one of your classes, I think I know, was a period 2 gentleman. No, was it period 1? I forget. Someone talked when they did their project early this year. They asked people like, what's your favorite, fast food place or favorite hamburger place? And they were the usual In-N-Out, I think like Chick-fil-A, something, maybe like Five Guys or whatnot. But they also mentioned Burger King. Okay, so we're gonna take a look at page 168. Can you read over that right now? Go ahead and pause the video and just read over this opening paragraph, okay? Hey guys, thanks for reading over that chapter. We've created a scatter plot right here based off of the protein as our explanatory variable and the amount of fat in grams as a response variable for the menu items, for the items on the menu of Burger King. Class, have you been to a Burger King? I don't know where there are Burger Kings in Pasadena. Do you all know? Maybe you can post in the comments and like my video. So how would you describe the scatter plot? Chapter 7, right? We used a DFSU. Okay, hopefully you can see that the form of this is linear, right? If I take my pen right here and put it right here, it forms a nice line. Any unusual features? No. Direction, definitely positive, right? And how about strength? How would you rate the strength of that? That looks pretty strong, right? Or maybe moderately strong. If you go to the next page, on the top page 169, it says that your R, your correlation coefficient, is 0.83, which is considered pretty strong. Okay. What we're going to do today is we are going to draw a line. Class, please don't tell Miss Scribner I'm doing this. In your textbook, and you can feel free to do this too, we want to draw a line of best fit. Okay? We want to try to figure out where would this line, like best fit, goes through kind of the middle of the data. It kind of looks something like right here-ish. Okay? This is what we call our line of best fit. Okay? They do this for you on page 169, but I just wanted to draw in the textbook. I felt rebellious today. All right. So this line of best fit has an equation, and let's talk about that. Okay. Okay. The equation that we have, we call a linear model. Okay. Linear model is talked about on page 169. A linear model is also known as a least squares regression line. Okay. Least squares regression line, or simply regression line, or also what we just mentioned, our line of best fit. Okay, so is it okay if I abbreviate? Least squares regression line, line of best fit. The term linear model, this implies, not always, and they usually put the word equation after this. This implies the equation, okay? Sure, when you have the equation, you can call it the line of best fit. You can call it the regression line equation. But when you say the term linear model, it implies the equation, okay? So the way we write this linear model, it's written in the form y hat equals a plus bx, okay? Your calculator uses this form. This is the calculator and AP. That's how they use it, right? But your textbook uses y hat equals b naught plus b sub 1 x. Okay, this would be your textbook. This is on page 174, right here. Okay. Do you guys remember back in the day, long time ago, you had y equals mx plus b? Do you remember that? I'm sure you do, right? The m represents your slope, which is your change in y over your change in x. You guys remember that? And your b represents your y-intercept. Let's just quickly go over that. So what that means is if you have a coordinate plane, okay, and you have a line that goes through right here, your slope would be this right here, right? It would be the change in your y over the change in your x, right? Delta y over delta x. And then also this right here would be your y-intercept, right? It's where it crosses your y-axis. Right. So when you look at this here, this A actually represents your y-intercept, okay? Same as a b naught, okay? Your slope is the b, okay? So if stats was not confusing enough, we are taking what you used to use, the y equals mx plus b, and we're changing it now, and we're using these forms. I think you should be comfortable with both, but if you only choose one, use this one right here, okay? Because this is one the AP uses, and then our College Board uses, and your calculator uses. This is the one from your textbook. Okay? So let's talk a little bit more about these. If on page 164, if you look at the very bottom, they give you the least squares regression line, the equation, down here, okay? So for the context of our Burger King question, our least squares regression line is y hat equals 6.8 plus 0.97 x. Or you can write it as fat hat, get it? 6.8 plus 97 protein, okay? Class, remember that protein is our explanatory variable, it's our x, okay? And then fat is our response variable, our y. What this hat means right here, this thing right here represents predicted, okay? Because remember our line, class, it's trying to predict. So what we're doing is, you notice that food items on their menu follow this trend, right? So let's say Burger King comes with a new item, okay? So then this new item has, I don't know, we'll say that's like 40 grams of protein. Miss Scribner's not gonna like this. Okay, so it's 40 grams of protein here. So can we make a prediction about how much fat, okay, how much good old delicious greasy all of your shirt fat are you gonna have if you have 40 grams of protein? Okay, well, of course, right? We can just use this and determine that would have approximately, I don't know, what is that, 50 or so? 50, a little bit more than 50 grams of fat. So we're trying to make a prediction on that. Okay? That's the fun we're going to have today. All right. So let me go and talk a little bit more about that equation. So when you have your y hat equals a plus b x, we've determined that that represents your y-intercept. Okay? So what does that actually mean? Like for this example right here, what does that mean that your y-intercept is 6.8 grams of fat? Well, if you look at this right here, if this is 6.8 right here, okay, your y-intercept is 6.8. What it's saying is that if you had a food item on the menu that was 0 grams of fat, okay, think about this, okay? Don't make this too mathy. If you had a food item on the menu that was 0 grams of fat, like a celery stick, there would be so much, 0 grams of protein, 0 grams of protein, that item would be predicted to have approximately 6.8 grams of fat, okay? So if we know that there is 0 grams of protein, your X, we predict that it would have approximately 6.8 grams of fat, all right? So we use a simple template, a little cheat sheet, okay? And I'm only going to give this to you because you're watching the video. People who don't watch the video, they don't need it, okay? So the way you're going to write this out when you're asked to interpret what the y-intercept means, you're going to say this: if explanatory variable unit is 0. Okay, so you're going to put it in context. If the explanatory variable unit is 0, this linear model predicts a response variable value of units. Okay. So if we write this in context using our Burger King example, if protein in grams is 0, this linear model predicts a fat value of 6.8 units, or 6.8 grams. Okay. So if the protein, if X is 0, we predict our Y to be 6.8. Okay, does that make sense? So now let's look at the slope. Okay, so the template for this, you guys remember when I wrote this down, your slope is the change in y over the change in x, right? Your rise over your run. Does that sound familiar? Rise over run. Does it bring back good memories? Okay. So the way you're going to write this is if for every 1 unit, whatever this unit, increase in, is it okay if I write explanatory variable as EV? For every 1 unit increase in explanatory variable, our linear model predicts an average increase or decrease. Okay, I'll talk about that in a moment. Increase, decrease of something units. This is your B in the response variable. Okay, so let's try this. For every 1 gram increase in protein, our linear model predicts an average increase of 0.97. Let me go back to our equation. It's in your textbook, right? So this is your slope right here. 0.97 grams of fat. 7 grams in fat. Okay. So the reason that we have this increase or decrease, that depends on the sign of your slope, right? If it's a positive slope, that means every time the protein increases, as a protein increases, your fat increases. Well, if you had a negative, right, direction, it would be for every increase in the x, there would be a decrease, right? So you would, instead of using increase, you would use decrease. So I suggest to you, class, that you write this down somewhere safe so you can refer back to this, okay? When you write this for a test or a quiz, you don't have to write it in the exact, like, verbatim, but it should have those components in it, okay? We can talk more about that in class. All right. So I just copied the scatter plot on page 168, and I'm going to go ahead and draw my line of best fit. Okay, and I don't know, maybe it just looks something like this right here, okay? So this is our linear model equation, our line of best fit, our least squared regression line, or a regression line. I'm just going to use line of best fit because it sounds like that's what most of you are most familiar with, okay? So in this, we have something called a residual. Okay, let's take, for example, this food item right here. Okay, let's pretend this is the, gosh, I don't even know what they serve at Burger King, but let's just pretend this is the Whopper. Okay, so the Whopper has a whopping 37.5 grams of protein, and fat, OMG, looks like 40-ish, okay? So this is the actual, okay, or observed, okay? And this is the actual Whopper, but based on our linear model, okay, this gap right here, this difference, we call this a residual, okay? I'm looking at page 169. Towards the bottom of page 169. That residual is your difference between your your actual observed, and then this right here, we call that our predicted value. Okay? So this is your actual or observed value of the Whopper. And then that difference is the residual, the difference from your actual to your predicted. Okay, and the formula for that, to subtract these, your residual is simply y hat minus y. Or you can look at it as, we're going to use y, just y. Okay. When we look at residual, we're only looking at the y-axis. Okay, not the x value. So if you notice a difference here, to here. Okay, that's how much we were off by. That's how much the actual Whopper was off from our predicted. Okay, so the way I remember this is I remember that residual is simply our observed minus our I wrote that wrong, class. I'm so sorry. The hat should be over here. Can you fix that, please? That's what I thought, right? It should be residual equals observed minus our predicted. Okay, because the hat is for the predicted. Okay? Or it's the residual equals our actual minus our predicted. Okay, so actual and observed, you'll hear those words being used interchangeably. Okay, but these symbols will be consistent. That's your observed, that's your predicted. Okay. So class, did our linear model, did it overestimate or did it underestimate here? Okay. What would you say this difference is right here? Okay, I'm looking at the bottom of page 169 right here. If it's observed minus predicted, right, this residual would actually be a negative residual. Okay, so when you have a negative residual, this is what we call an overestimate. If it's a positive residual, this is what we call an underestimate. Okay, see the green box on page 169. This is kind of confusing because you would think like a positive would be over, but it's actually the opposite. So don't go with your gut. Don't go with common sense. Go against common sense, right? Yeah. Okay, guys. Hey, we're going to clean this up in class. We're going to talk a lot more about this, all right? But I have a secret. Okay. I have a secret for you. So we are going to have a scavenger hunt, okay, on Tuesday at 8:20 a.m. So before class, right? Class starts at 8:30. Oh, this is for period 1, but for period 2, start at 10:25. So we'll start at 10:15 a.m. where I'm going to be passing out extra credit. All right. So I want you to turn on your cameras and you're going to show me certain things from the scavenger hunt. Okay. So if you're able to do that, then you'll earn extra credit in the form of Fukao bucks. Shh, don't tell anyone.